Hello viewers, welcome to our online channel. I am Dr. Archana Chaube, Faculty of Science from the Department of Chemistry, Bhopal School of Social Science. Today we'll be dealing with an important topic of physical chemistry, that is phase equilibrium. In today's lecture, we'll be dealing with some important initial topics. We'll be seeing the important terms, phase, component and degree of freedom. Then we'll discuss the Gibbs phase rule and what is the meaning of phase diagram. So let's begin. What is phase? Phase, if we define, it is a homogeneous and physically distinct, mechanically separable portion of a system by which which can be separated from one another in such parts so that the system may be defined to have specific definite boundaries. Once again, if I discuss what is the meaning of phase, phase is defined as a homogeneous, physically distinct and mechanically separable portions of a system which is separated from one another in a system with definite boundaries. Like for example, if you take a glass of water, water is filled in it, and if I put a piece of ice into it, so we can separately see, it means that you can distinct where is water and where is ice. So it has separate distinct boundary. You know that where the ice begins and where it is ending. So that means there are two different phases in this example which we are discussing. What we said, what is a phase? It is anything which is physically distinct and which can be mechanically separated from the system, and it has definite boundaries. Moving ahead to the second important term, that is component. What are components? Components, if we define, are the least number of chemical constituents by means of which the composition of each phase can be expressed in the form of an equation. Like, for example, if you take water system, we know that water exists in three different states: ice, which is the solid state, water, that is the liquid state, and steam, that is the vapor state. So these are the two different phases of water, because we can, just now we discussed ice and water together, so you could easily distinct the two. So similarly, this system of water, it has three different phases. But if I talk about the chemical composition, we know ice also will be expressed by the formula H2O, because its chemical composition is H2O. Same in case of liquid water and same in case of steam. So to express all the three phases in this water system, we only need one chemical composition, which is H2O. So it is a one component system. Taking another example, the decomposition of calcium carbonate. If we look at this equation, calcium carbonate is a solid which decomposes to form calcium oxide and carbon dioxide. So two solids and one gas. That means how many phases are there? There are three phases in this particular system of calcium carbonate undergoing decomposition. Now, since we are talking about the chemical constituents or the number of components that are required to describe this system. So what did we say? That if we take this example and I want to express the composition of all the three phases, calcium carbonate, calcium oxide and carbon dioxide. So I need at least two components to be present so that I can express the composition of the third one. Like the first equation, the composition of calcium carbonate can be obtained by adding calcium oxide and carbon dioxide. Calcium oxide individually, if I am taking, that means calcium oxide alone and carbon dioxide can be ignored. Similarly, for carbon dioxide, calcium oxide can be ignored and carbon dioxide itself, it is present to show the composition of CO2. So, if in this case we are taking calcium oxide and carbon dioxide, we can express the composition of the two individuals as well as calcium carbonate. Similarly, if I now want to take calcium carbonate and calcium oxide, now here again we can represent the three equations. Calcium carbonate itself is present, which undergoes decomposition to give you calcium oxide and carbon dioxide. So, this itself has its own composition. Now, if I want to know the composition of calcium oxide, that is also we have already taken. While for carbon dioxide, if I want to express the composition of carbon dioxide, it can be obtained by subtracting calcium oxide from calcium carbonate. Mathematically, if you subtract, we obtain carbon dioxide. So, what did we understand from this? That to express the composition of either of the components, you need at least the composition of two components from the equation to know the composition of the third one. So, therefore, this example of decomposition of calcium carbonate is a two component system. That means at least two components must be known so that you can express the composition of the third one. Moving to the third important term. Just now we have discussed what is phase and what is component. Now we will be discussing what is the meaning of degree of freedom. So, if I define, it is the least number of variable factors of a system, such as what? Temperature, pressure and concentration, that must be specified so that the remaining variables are automatically fixed and the system can be completely defined. The word itself suggests the degree of freedom, how much freedom you have to change any variable. So, if you have the freedom to change one variable and the remaining are fixed, that means the system has the degree of freedom 1. So, it is known as univariant system. If two variables you have the freedom to change their values and you can still define the system, that means its degree of freedom is 2 and it is termed as bivariant system, and so on so forth. And if there is such a condition where nothing can be changed, each and every property such as temperature, pressure, concentration needs to be fixed, then only the particular composition of the phases can be expressed. That means we have no degree of freedom, or we may say that the degree of freedom is 0, and such a system will be known as invariant या non-variant system. So, invariant or non-variant system is a system in which none of the variables can be changed. They have their fixed values. For a specific temperature, pressure, concentration conditions only the equilibrium will be established. Now, once we have understood the three important terms, we come to the main point, that is phase rule, or it is famously known as Gibbs phase rule, the name of the scientist who actually give this expression. What is Gibbs phase rule? It is a simple general relationship which is established between the variance, or it is actually the degree of freedom that we were talking about, which is represented by capital F, variance, because it can be varied. It is also known as variance or degree of freedom. So, phase rule is what? It tells the relationship between the variance, the number of components and the number of phases which are present in equilibrium during a system, and mathematically the relationship is expressed by the formula F is equal to C minus P plus 2, where what is 2? 2 is an intensive variable such as temperature and pressure, in the terms of which we will be drawing various diagrams which are known as phase diagrams. That will be continuing in the earlier videos. So, this is the Gibbs phase rule. Again, we will see the mathematical relation. It is a relation between the degree of freedom components and the phase which are present in a system, and its expression is F is equal to C minus P plus 2. Now, since I have told you that if you have the number of chemical composition, like in case of water it is H2O, so it is a one component system. There are many such examples like water system, carbon dioxide system, sulfur system. They all are examples of one component system where only one composition is sufficient to describe all the various phases of that particular system. In such a one component system, if you see this graph, this is actually a phase diagram, and this is the phase diagram of a water system. We will be dealing it in detail in the next video. Here I am just showing you to understand what is a phase diagram. It is such graphical representation where on one of the axes we take the property variable pressure, and on other we have taken temperature, and there are different portions of this phase diagram, like O is the center which connects to the line A, C and B. Now, in this case, we can divide this full phase diagram into areas. These are the areas, like AOC, this is one area, AOC. Similarly, it will be BOA and BOC. This is one area and this is another area. So, in a way, this water system, it has three areas into it, and these areas are divided by lines. So, there are areas, there are lines or curves. These lines are also known as curves, and there are specific points into it. So, now we will be discussing what are the meaning of lines, areas and curves. If we talk about a phase system, there can be three cases which will arise. First, when only one phase is present. So, I told you just now, when we apply the Gibbs phase rule, F is equal to C minus P plus 2. So, where F is the degree of freedom and P is 1 in case of when one phase is present. So, if you write 1 over here in case of P and it is a one component system, so it will be F is equal to one component system, C is 1. I am saying that it is a one phase system. So, that means P is also 1 plus 2. So, 1 minus 1 gets cancelled and the value of F comes out to be 2. That means what? It is a bivariant system. So, any system in which it is one component and the phase is 1, the value of F will be calculated and mathematically it comes out to be 2, which means it is a bivariant system. Similarly, if in case of P, if I write 2, again it is a one component system. So, the value of C is 1. In case of P, now I am assuming that it is a two phase. So, 1 minus 2 plus 2. So, this plus 2 minus 2 get cancelled and the answer of F comes out to be 1, which means the degree of freedom over here is 1 and it is a monovariant system. While similarly for three phases, when they are in equilibrium, so when you put the value for P is equal to 3, then the answer for F comes out to be 0, which means it is a non-variant or invariant system. And just now I discussed that in case of invariant system, all the values of temperature, pressure has to be specified. That means you do not have any degree of freedom. There is no freedom to change the values. It will only appear at specific conditions of temperature and pressure. Now, this diagram we just discussed, this is known as a phase diagram, or it is also known as equilibrium diagram, phase diagram or equilibrium diagram. And here on one axis we take pressure and on the other axis we take temperature. Now, if we discuss about the phase diagram, these are the three salient features. That means a phase diagram can be divided into areas, curves and triple point. In case of this water system, since we are talking about a one component system, it is a water system is the simplest example that can be taken. So, in case of water system or the one component system, these are the three states in which water appears: solid, liquid and vapor, and it is shown in the three areas: solid, liquid and gas. These are the three areas of that particular phase diagram. Also, there will be three different curves and each curve is termed by a specific name depending on the process that is occurring. Like for example, we know when a solid gets converted into liquid, the process is known as melting. So, the curve which identifies and differentiates the interconversion of such two states, it is known as the melting point curve. And just now we have seen that when there are two phases in equilibrium, the value of degree of freedom comes out to be 1. That means it is a univariant system. All the curves will always be univariant, areas will be bivariant and specific points will be invariant or non-variant. So, in case of water system, we have three different curves. One is the melting point curve where solid and liquid are in equilibrium. Second is where liquid and gas or vapor is in equilibrium. It is known as the vapor pressure curve. And the third, in which solid is in equilibrium with vapor. The process is known as sublimation. So, these names for the curves are given on the basis of the process that is occurring: melting, melting point curve; vaporization, vapor pressure curve; and the process of sublimation is the sublimation curves. So, there are three areas and three curves. And then there comes the specific point, which is the triple point that we were discussing, the non-variant or the invariant point. This point, in case of water system, it is the place where all the three phases will coexist. Like it is very difficult to see a condition where water, ice and vapor all are existing together. So, normally it is not possible at normal pressure temperature conditions. So, it will exist at a specific condition. So, that is why this point is an invariant or non-variant point where the degree of freedom is 0. That means temperature and pressure will be fixed and specific. So, this is all about the general phase rule and the important terms related to phase equilibrium. In the next video, we will be discussing in detail the one component system, that is the water system. Thank you.